So I'm going to do a run through of my poster titled From Eye-Fixation Sequence to Knowledge Representation, Utilization of Network Science. This is basically a study focusing on assessing people's reading comprehension ability. We chose this topic because the ability to efficiently integrate and obtain information during reading contributes significantly to one's learning outcome. And to study this, we chose two sets of tools. One is eye tracking, the other one is network science. This is because eye movements have been used a lot in reading comprehension studies as a online indicator of people's reading process. In this study, we not only want to look at people's comprehension results, but we also want to have a sense of the trajectory of their information processing process. So this is why we chose eye tracking technique. And for network science, it's actually not new. It has been applied to a variety of fields already, including sociology, computer science, and linguistics, etc. And this is basically a tool to extract higher order architectural properties. So for our current study, what we did was we first extracted readers' word level fixation onsets in order to construct their individual eye fixation sequence. And then in the next step, we used these fixation sequence by feeding them into a aggregation algorithm and constructed individuals' mental representation network. Because the mental knowledge organization cannot be assessed directly, so this is the way that we chose to closely represent that. And for the third step, we used some most commonly accepted graph metrics to evaluate and quantify each individual representation network. These metrics included small wordness, density, and centrality. And our hypothesis is that these graph metrics of the representation network should be significantly correlated with readers' comprehension ability because essentially it's derived from people's eye movement patterns during reading. For the participants and material, we recruited 22 monolingual native English speakers. They all have a normal and corrected vision. And the material we used is a scientific text about Mars exploration. And we presented it on the screen to our participants sentence by sentence. For the behavioral tests, we did a gray silent reading test. This is basically a standardized test which assesses people's reading comprehension ability. And we also conducted a reading background questionnaires to grab some language and reading habit background of our participants. The equipment we use is the iLink 1000 Plus long range mounted eye tracker. So for the measurements in more detail, readers' reading comprehension ability was measured as a combined normalized score instead of just like a single score. So by deriving this combined score, we basically accounted for their accuracy when answering the multiple choice questions right after the reading task, and their standardized reading ability assessment, and their reading time as well. So basically, we were trying to find the readers who read the most accurately as well as most efficiently. So for the fixation sequence, what we did was that we entered it into a aggregation algorithm, and we counted every word a specific reader looked at as a node. And then for the cause, every saccade that they made during reading was counted as edges in the graph. And repetitive notes caused by recurring words in our text were merged together as one. And these are what we get as the representation networks. So for the left one, it's the average representation network of our most skilled readers, which was our top 10 readers who read um, in a faster manner as well as more accurately. And on the right is the average representation network of our less skilled readers. And every single node here represents a word that they've visited, and every edges represents a saccade. Please note that when calculating these averaged representation network, we applied a mask on it, so there is a certain threshold within these 10 people. If a node got visited more than 3 times out of 10, then it would be counted as a node in this averaged network. Otherwise, it's faulted out here. And for the size of nodes, if the node is larger, that means the specific word, for instance, Mars here, got visited more. And if like this edges here is thicker, then it means there's more transmission in between these two nodes. Here, I think the thickest transition or edge among all is the one from Mars to Earth. That means people like visits a lot from Mars and Earth and back. And so as you can see, the skilled readers network looks more sparse and like less complicated compared to the less skilled readers. It's also less dense, and this is quite straightforward. You can basically tell with a single glance at it. And so in the skilled readers network, the total number of nodes is just 28, while in the less skilled readers, the total number of nodes was 47. No, sorry, 43, which means that the less skilled readers made a lot more overall fixations compared to the skilled readers, and the skilled readers actually skipped more words during their reading process. Also, for the center node, which is Mars, and it's also the topic of our text, the note degree for this Mars word in the skilled readers network was just 31, and for the less skilled readers it's higher, it's like 38.8. So this is telling us that the less skilled readers are linking related concepts more directly to the center topic. In Royce, in one of previous literature from Dr. Clariana, looking at how centrality can represent someone's understanding of a scientific text, the assumption was that more naive readers would tend to link related concepts with only the center topic, while more skilled readers knows how to make connections among these surrounding related concepts instead of just like naively linking all of them back to the center concept. And another interesting thing we noted here is that for the less skilled readers, they looked at more functional words like off, like this, and on, like and, words like this, while a skilled reader tend to just skip those function words because they're just not informative. And for our results, we ran a simple correlation among people's reading ability and their graph metrics, including density and small awareness. Small awareness is represented in light blue here, and density was represented in dark blue. By reading ability, we meant the combined reading score. So basically, counting for both their speed and their accuracy during reading. And as we can see, there is a significant negative correlation between both of these network metrics and people's reading ability. So we concluded that participants' reading comprehension ability is significantly correlated with their network density and their network small awareness metrics. And our interpretation was that better readers' representation network generated by their fixation sequence during reading exhibited lower density and lower small awareness. And skilled readers are therefore less likely to fixate on repetitive words as well as functional words during reading. Um, for the references, you can actually find not only the reference of this poster, but also the whole data set on the Open Neural platform. And if you're interested in exploring our data yourself, you can just scan this barcode and get access of it from the Open Neural platform. And if you have any questions or concerns about this study, please feel free to contact me at this email address.